Good morning. This is Srikanth, Assistant Professor of EEE Department. In this session, I am going to cover Reciprocity Theorem. The statement of Reciprocity Theorem. First, let us go with the statement of Reciprocity Theorem. In a linear bilateral network, the ratio of response at one port to the excitation at another port is equal to the ratio of response at the second port to the excitation at the first port, provided that excitation at one port is 0. Here, when we are having a single source network, the response to the excitation is same when we interchange the positions of response and excitation. So, in this theorem, it works on the principle of linearity. It reveals the symmetrical behavior of the linear circuits where the effects of current sources at different locations can be interchanged without changing the overall behavior of the circuit. A current or voltage source is located at a point X here at point X, and its effect on the another point Y is measured. The same current or voltage source is now located at point Y, and its effect is measured at the point X. So in both the scenarios which we are going to get, the EMF ratio between points X and Y remains the same. This shows that reciprocity of the circuit. If let us take, this is the example, here is the voltage which we are taking, and here is the current we are going to calculate. Response to the ratio of response to the excitation. Response is V and excitation is I in the first case. And in the second case, when the voltage is connected at B point and A is short circuited, let us consider it as I dash here, which is equals to V by I dash. From this we can get I is equals to I dash. So in both the cases, whenever we change the positions of response and excitations, the current or voltage flowing through the any element is same in two cases. So these are the some of the applications of reciprocity theorem. One is antenna design. The reciprocity theorem is fundamental in designing efficient antennas for wireless communication systems and signal integrity analysis. By understanding the reciprocity property, engineers can accurately analyze and predict signal behavior in complex circuits. And circuit modeling, the theorem aids in developing accurate models of circuits and facilitate circuit analysis and design. And the major problem is here in the reciprocity theorem, there are certain limitations. The one is it is not applicable for non-linear circuits. The theorem's applicability is limited to linear circuits, and its accuracy decreases in the presence of non-linear elements. And the next one is in circuits where time varying elements are involved, such as capacitors and inductors, the reciprocity theorem does not hold. Whenever we are having capacitors and inductors, these are the time varying elements. because the voltage current relationships are depends on differentiation and integration. So this reciprocity theorem does not hold for such type of circuits. And magnetic field interaction, the theorem does not consider the effects of magnetic field interactions, limiting its usefulness in certain scenarios. And from this, we can conclude that the reciprocity theorem is a powerful tool in electrical circuit analysis and design, and it enables to simplify complex circuit problems and predict circuit behavior accurately. And we can also understand the limitations of the theorem. By understanding the limitations of the theorem, which helps in identifying situations where alternate methods must be employed. So these are certain things, certain limitations we need to remember. And with the linear circuits, it is a most powerful technique to predict the circuit behavior. Now let us go with the example. Let us let us consider this 45 volts is the input and the exit response is the I. Let us consider I dash. So we need to calculate what is the I dash. So in order to calculate the I dash, we have to either we have to go with mesh or nodal method or circuit reduction method. So here, if you see, it is easy with the circuit reduction method. So let us calculate what is the equivalent resistance between AB terminals. So here, if you see from these two terminals, the equivalent resistance will be here. This 2 ohms and 4 ohms are connected in series. 2 ohms and 4 ohms are connected in series. 2 ohms and 4 ohms are connected in series. So R equivalent 1 is equals to R1 plus R2, that is equals to 2 plus 4, which is equals to 6 ohms. Now let me redraw the circuit with the 6 ohms. 6 ohms, 6 ohms and 12 ohms. Between AB terminals are equivalent. So here if you see this circuit, this 6 ohms and this 6 ohms are connected in parallel. 6 ohms and 6 ohms are in parallel. So R equivalent 2 is equals to 6 into 6 by 6 plus 6, that is equals to 3 ohms. Now our circuit will become 12 ohms and 12 ohms and 3 ohms. And here we are going to apply 45 volts. Now let us calculate what is the current. So the current is equals to V by are equivalent. Here this 12 ohms and 3 ohms are connected in series. So 45 by 12 plus 3, which is equals to 45 by 15, which is equals to 3 amperes. So now we got the total current as 3 amperes. Here you can see this current, we got it as 3 amperes. Now we need to calculate what is the current in this 4 ohms. So I dash is equals to, and if you take these two are in series, that is the equivalent resistance, we got it as 6 ohms. This 6 ohms are connected in parallel. So equal resistances are connected. The current will be divided equally. So I dash is equals to 3 by 2, which is equals to 1.5 amperes. So now in the first case, we got the I dash value as 1.5 amperes. Now we need to check the current when we interchange the positions of response and excitations. Here we are going to interchange the positions of response and excitation. Here voltage source, if voltage source is there, that is replaced with short circuit, and current source is there, that is replaced with open circuit. And here I am adding the voltage source, that is of 45 volts. 45 volts, 4 ohms, 2 ohms, 6 ohms, and 12 ohms. Now here we have to see the circuit terminals from these 2 points A and B, where the voltage source terminals are connected. So if you see from these 2 terminals, the equivalent resistance we can calculate. Let us remove the voltage source in order to calculate the equivalent resistance. A, B terminals. Here it is 4 ohms, 2 ohms, 6 ohms, and 12 ohms. Now between AB terminals, if you see that circuit, this 4 ohms and 2 ohms are connected in series, and 12 ohms and 6 ohms are connected in parallel. So 2 ohms and 4 ohms are in series. 2 ohms and 4 ohms are in series. So R equivalent 1 is equals to 2 plus 4, which is equals to 6 ohms. And 6 ohms and 12 ohms are in parallel. 6 ohms and 12 ohms are in parallel. So R equivalent 2 is equals to 6 into 12 by 12 plus 6, which is equals to 72 by 18, which is equals to 4 ohms. So our circuit will become only two resistance, that is one is of 6 ohm resistance and another is of 4 ohm resistance. A, B terminals. So from this, R equivalent is equals to 6 plus 4, which is equals to 10 ohms. So now we got the total equivalent resistance is 10 ohms. So we are going to get the current I is equals to 45 by total equivalent resistance, we got it as 10, that is equals to 4.5 amperes. Now we got the 4.5 amperes. This 4.5 amperes is divided into two, that is I dash, I double dash we need to calculate. So I double dash is equals to I into opposite resistance is 12 divided by, sorry, I into opposite resistance is 6 by 12 plus 6, which is equals to 4.5 into 6 by 18. 6 ones are 6 threes are 4.5 by 3, that is 1.5 amperes. So we got I double dash as 1.5 amperes. Hence I dash we got it as 1.5 and I double dash is equals to 1.5. Hence reciprocity theorem is verified. Reciprocity theorem is verified. Verified. So these are the steps to follow the reciprocity theorem calculations. Now we'll go with the another example with different combination of resistors. So here we need to calculate what is the current flowing through the 5 ohms, so that we can check if we interchange the positions whether we are going to get the same current or not. We are going to see. So first let us consider this current as I2. So when we are considering this current as I2, now in this example we will go with the nodal method. So different methods we are going to see for the different circuits based on our interest and easy to solve. That is, let us consider this node voltage as V1 and the reference node voltage as 0 volts. Now if we write the KCL at node 1, KCL at node 1, that is V1 minus 20. All the currents are leaving from the node. V1 minus 20 by 10 plus V1 by 10 plus V1 by 5 plus 5 is equals to 0. If we take V1 common, 1 by 10 plus 1 by 10 plus 1 by 10, which is equals to 2. V1 into 3 by 10, 3 by 10 is equals to 0.3, which is equals to 2, where V1 is equals to 2 by 0.3, that is equals to 20 by 3, 6.66 volts. So now we got 6.66 volts. as the voltage. Now we need to calculate what is the current flowing through this 5 ohms. So for calculating current, let us consider the current as I2. So I2 is equals to V1 by, here 5 plus 5, two resistors are connected in series, V1 by 5 plus 5, that is equals to 6.66 by 10, which is equals to 0.666 amperes. This is the first case. At the normal positions, the response value we got it as 0.66 amperes. Now when we interchange the positions, let us see what are the values we are going to get. Now when we interchange the positions, let us consider this value as I2 dash. Let us consider this value as I2 dash, and here the voltage source is 20 volts which is connected. Now in the same way, here let us consider the voltage as V1 dash, and the ground voltage as 0 volts. Now if we write the KCL at node V1 dash by 10, all the currents are leaving from the node, V1 dash by 10 plus V1 dash minus 20 by 5 plus 5, which is equals to 0. Which we can get it as the V1 dash into 1 by 10 plus 1 by 10 plus 1 by 10 equals to 2. So V1 dash is equals to 2 divided by 0.3, that is equals to 20 by 3, 6.66 volts. So here we got V dash also same, and I2 dash is equals to V dash by 10, that is equals to 0.666 amperes. So we got I2 is equals to I2 dash, hence reciprocity theorem is verified. Reciprocity theorem is verified. Verified. This is our calculation for reciprocity theorem using nodal analysis. Now we will go with the current source. When we are having a current source, how we are going to get the response? We are taking it as voltage V0. Okay. So here, when the current is flowing, when there is a current source, here is the current which we are getting, and this current will be divided into two, I1 and I2. If you see the circuit, these two resistors are connected in series. So this is 2 plus 2, 4 ohms, and these are total two parallel resistances are connected. So the current which will be divided into two parallel resistances is same. So that is I2 is equals to I by 2 because of parallel equal resistances. So that is equals to 20 by 2. which is equals to 10 amperes. Now we got the current here as 10 amperes. Now we got the current here as 10 amperes, where V naught is equals to 2 into 10, which is equals to 20 volts. 2 into 10, which is equals to 20 volts. Now we got the V naught value as 20 volts. This is when the current source is at normal position. Now we are going to interchange the positions of the current source and the response. Here the current source position is changed, that is, which is connected in parallel to the resistance, and here we are going to calculate the V naught dash. Here we are going to calculate the V naught dash. Here it is a current source, so we have to open circuit. So no current will flow through the 8 ohm resistance. No current will flow through the 8 ohm resistance. So voltage across 4 ohm resistance is nothing but the V naught dash. Voltage across 4 ohm resistance is nothing but the V naught dash. So now if we replace the circuit with only 4 ohms and 2 ohms, 2 ohms, 20 amperes. Here this 20 amperes is the current value which is given in this circuit. Now we need to calculate what is the voltage across 4 ohms. Now if you see the circuit, these 2 ohms and 4 ohms are connected in series. 2 ohms and 4 ohms are connected in series. Connected in series. So 2 plus 4 are equivalent 1 is equals to 2 plus 4, which is equals to 6 ohms. Now if we replace the circuit with, now we got the 6 ohms, which is in parallel with the 2 ohms, 6 ohms, 2 ohms and 20 amperes. So we need to calculate what is the current flowing through 6 ohms, because we need to calculate what is the voltage V naught dash. So here the 20 ampere current source current is dividing into 2, that is, let us consider this as I2, this is I1, where I2 is equals to 20 into 2 by 20 plus opposite resistance, 20 into 2 by 20 plus, sorry, not 20, 6 plus 2, which is equals to 40 by 8, that is 5 amperes. So this is the current which we got in the 6 ohm resistance, that is nothing but whatever the current which is flowing through the 4 ohm resistance. So V naught dash is equals to I2 into 4 ohms, that is equals to I2 value 5, 5 into 4, which is equals to 20 volts. So we got V naught is equals to V naught dash. Hence, reciprocity theorem is verified. And the next one is, in all the three cases, we have taken the examples such that at the starting point and ending point of the terminals, which we have considered for calculation of response and excitation. Now, in this example, we are taking the calculation of a response in the middle portion of the circuit other than the starting and ending. So in this example, first let us consider the current as I dash. So here, in order to calculate the I dash value, let us consider the node voltage as V1, and which is at ground volt 0 volts. So KCL at node 1, KCL at node 1, that is V1 minus 12 by 2 plus V1 minus 0 by 4 plus V1 minus 0 by 6, which is equals to 0. If we take V1 common, 1 by 2 plus 1 by 4 plus 1 by 6, which is equals to 6, where V1 is equals to 0.916, which is equals to 6.55 volts. So here we got the V1 value as 6.55 volts, where I dash is equals to V1 by 4, which is equals to 6.55 by 4, 637 amperes. This is the I dash value we got. Now let us go with the calculation by replacing the positions of response and excitation. Here, when we interchange the positions of response and excitations, again let us take the V1 dash, here the I double dash, and here the ground voltage is 0 volts. Now the KCL at node 1, KCL at node 1, that is V1 dash minus 0 by 2 plus V1 dash minus 12 by 4 plus V1 dash by 6 is equals to 0. V1 dash, if we take common, 1 by 2 plus 1 by 4 plus 1 by 6, which is equals to 3. 12 by 4, which we are going to get it as 3. V1 dash is equals to 3 by 0.916, 3.275 is the voltage we got it at V1 dash. Now I double dash is equals to V1 dash by 2, that is equals to 3.275 by 2, that is 1.63 amperes, 637 approximately we get. So here we got it as I double dash as 1.63, I dash as 1.63, I is equals to, sorry, I dash is equals to I double dash. Hence, reciprocity theorem is verified. Reciprocity theorem is verified. So in this session, we have discussed what is reciprocity theorem and what are the steps to follow and what are the applications and different examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.